In this lesson, we're covering classifying quadrilaterals on a coordinate plane. So to classify a quadrilateral as a parallelogram, a rectangle, or rhombus, or square, we have to follow two steps. The first step is to check the congruency of the sides, and the second step is to check the congruency of the diagonals. So now we're looking at these four cases below to check to see if the quadrilateral is simply just a parallelogram. You want to see if the opposite sides are congruent and the diagonals are not congruent. So let me get my pen here. Alright, so we want to check for congruency on opposite sides for a parallelogram. The diagonals do not have to be congruent. For case 2, the opposite sides are congruent and the diagonals are also congruent. So right here, we will have congruency there, but the diagonals will also be congruent as well. Alright, case 3, if you're checking for a rhombus, all four sides are congruent and the diagonals are not congruent. So you just check to see if all sides are the same. And then case 4, for a square, all four sides will have to be congruent and the diagonals will have to be congruent as well. Alright, so I'm going to do 2 examples with you, and the last one, the third example, you're going to try on your own. Let's get started. Looking at this example here, example 1, it says given the vertices, determine the quadrilateral's most specific classification. I'm given these 4 ordered pairs, so I want to find the length of each side and the length of each diagonal and compare them. So to find the length of each side, I just use the distance formula, and I'm going to start out with side AB. So I just label it x1, y1, x2, y2, and plug it into the distance formula. So x2 minus x1, that will be 8 minus 9 squared. Plus negative 2 plus 4 squared is equal to 1 squared, because 8 minus 9 is 1, and so that's negative 1 squared actually. Plus negative 2 plus 4 is a positive 2, so that's 2 squared, and we're left with 1 plus 4. Simplifying that, and I'm left with the square root of 5 for AB. Next, let's find side BC, so I'm going to label x1, y1, x2, y2, using the same process, plugging it in. 2 minus 8, so x2 minus x1 squared plus negative 5 plus 2. Again, we got that double negative. We have minus a negative, so minus in the formula, and we have that negative 2 there. Simplifying, I'm going to simplify this a little bit in my head. So 2 minus 8 is 6, negative 6, and negative 6 squared is 36. Alright, and then negative 5 plus 2 is negative 3, and negative 3 squared is positive 9. And I'm left with 36 plus 9, which is 45. We want to write the exact answer so we could analyze each side there. So I want to write it in simplest radical form. So remember, to write it in simplest radical form, you're going to find 2 factors of this number, which is 45. And one of those numbers have to be a perfect square. So 2 factors are 9 and 5, because 9 is a perfect square. I take the square root of 9 because that is my perfect square. Bring that outside the radical, and I leave my 5 under the radical. So I have 3 square root of 5, and I also have square root of 5. So finding my other side here, same thing, distance formula, side CD. So x1, y1, x2, y2. 3 minus 2 squared plus negative 7 plus 5 squared. So just finding the length of each side. Simplifying that, I'm left with 1 plus 4, and I'm left with the square root of 5. Alright, next, AD. Labeling this x1, y1, x2, y2. Let me change colors here. X1, Y1, X2, Y2. So right here. So that it will be 3 minus 9 squared plus negative 7 plus 4 squared. As we can see, this is a long process. Simplifying that, 3 minus 9 squared is negative 6, and negative 6 squared is 36. Negative 7 plus 4 is 3, negative 3. Negative 3 squared is 9. It looks like I'm going to get the square root of 45, which is 3 square root of 5. So at this point, I could see that it will either be a parallelogram, hope I spelled that correctly, I'm trying to write fast, or a rectangle, because my opposite sides are congruent. I got two sides that are the square root of 5 and two sides that are the square root of 3. So we got to narrow it down a little bit more by finding the diagonals. And our diagonals would be AC, so we'll use every other letter because it's going to cross over. So diagonals AC, A and C. So let me just erase some of these X1, Y1 thingies up here. Alright. So AC, I'm going to use X1, Y1, X2, Y2. Plugging it in. That would be 2 minus 9 squared plus negative 5 plus 4 squared is equal to the square root. So simplifying that, 2 minus 9 is 7. 7 squared, or negative 7. 7 squared is 49. This would be 1. So plus 1, I get square root of 50. And that leaves me with 5 square root of 2. I break it up into 25 and 2. And last one, a lot of work here. Distance equals, so my diagonal, so every other letter here would be BD. Let's just change colors here. X1, Y1, X2, Y2. So plugging that in, let's see, 3 minus 8 squared plus negative 7 plus 2 squared equals 25 plus 25. So I still have a square root of 50 underneath, and I'm left with 5 square root of 2. Because it's going to be 50, and I have 50 up here, right here. So I know it's going to be 5 square root of 2. So my diagonals are congruent. So I have opposite sides that are congruent and opposite angles that are congruent. And so that tells me that ABCD is a rectangle. Because in a rectangle, the diagonals are congruent. So that is my most precise classification there. And that says rectangle, long problem. So I'm kind of writing it kind of, so that says rectangle. So this would be a rectangle. All right, so let's try another one. All right, so let's take a look at this example here. It will take a little less time because there is pre-written, so I'm just gonna be showing you showing you the distance formula for each side. So first for side JK, when we plug it into the distance formula, we get 3 square root of 2. If you still need a little help with distance formula, please just pause the video and see what work was done here. Then we find KL, and we get square root of 73. We could not break that up. LM, we get 3 square root of 2. And for JM, we get square root of 73. So we can see that, again, opposite sides are congruent, so we can conclude that it's either a parallelogram or a rectangle. But now we need to find the diagonals. So JL, remember the opposite letters here. So that would be the square root of 57, and the KM would be the square root of 5. So the diagonals do not match. All right, so in a rectangle, the diagonals do match, right? So it cannot be a rectangle, so it would have to just be a parallelogram. All right, so for this last problem, I would like for you to pause the video and try it on your own. So you have to find each side and then the diagonals. So remember, after you find each side, look at what the quadrilateral rule could be. Then when you find the diagonals, narrow it down a little bit more. So go ahead and pause and try it on your own. Alright, so this is actually a rhombus. So after you find the sides, you see that all the sides are congruent. So it will either be a rhombus or a square, the most precise, because in a rhombus and square, all of the sides are congruent. And then once you find the diagonals, you can see that they are different. So it would have to just be a rhombus, because in a square, the diagonals are congruent. So the most precise name for this quadrilateral would be a rhombus. So hopefully you got it correct. If not, pause the video and just analyze the work a little bit more. We reached the end of our lesson. I want to thank you for learning with me. Some related videos are perimeter of polygons using coordinates and properties of rectangles. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.